Hello and welcome. In this video we're going to look at example 3 from section 8.2, which asks, find the area of the surface generated by revolving the curve x equals 1 plus 2y squared from y going from 1 to 2 about the x-axis. And here we're actually not even going to draw a picture. We're going to launch right into the surface area formula. So that's going to be the integral of 2 pi r ds. Again, it's the surface area, it's the circumference of the circle times a little infinitesimally small piece of the arc, ds. We're adding up all of those to kind of cover the entire surface area. So now what we're going to do is think, all right, what are we going to replace r with? Well, we're rotating with respect to, we're rotating about the x-axis, and so a radius is going to be y, right? Y is going to be the length of that radius. So we're going to replace r with y. This is because we're rotating about the y-axis, the x-axis. Now the ds we have choices about. Here we're given x as a function of y. X is equal to 1 plus 2y squared. So let's go with the version where we find dx dy, which has a dy in it. So we're going to go with the version that's square root of 1 plus dx dy squared, and then dy, which means we're going to be integrating with respect to y, and that's because of the dy there. Okay, so we have the square root of 1 plus dx dy is what here? Looks like 4y, and then quantity squared with a dy. And notice everything is already in terms of y, which is great. So let's go ahead and label our limits of integration. We have y goes from 1 to 2. And we'll take our 2 pi out. So we have in the 2 pi times the integral from 1 to 2 of y times the square root of 1 plus 16y squared. Okay, what technique are we going to use to find the antiderivative here to finish off this integration? If you said substitution, that would be correct. So here we're going to let u equal 1 plus 16y squared. The du is 32y dy. Now we'll move the 32 over. We have 1 over 32 du equals y dy. Let's go ahead and change our limits of integration since we're changing our variable. So when y equals 1, we have u equals 1 plus 16 times 1 squared, which is 17. And when y equals 2, we have u equals 1 plus 16 times 2 squared, which gives us, let's see, that's 64 plus 1 is 65. So now we have 2 pi times the integral from 17 to 65 of the square root of u times 1 over 32 du. There we go. The 1 over 32 can come out with a 2 pi and turn into pi over 16. And then the antiderivative of the square root of u is going to be 2/3 u to the 3 halves. So 2/3 u to the 3 halves from 17 to 65. And then we can plug in our limits of integration. We'll plug in our limits of integration, and we've got, actually we could take the 2/3 out for one thing. Let's take the 2/3 out. That's kind of nice. The 2 and the 16, the 2 and the 16 will cancel, and we'll get pi over 8 with a 3 on the bottom, so that's going to be pi over 24. And then when we plug in the 65, we'll have 65 to the 3 halves minus 17 to the 3 halves. Those are not really very nice numbers, so we'll leave it at that. So in summary, if you want to rotate about the x-axis, you're going to have the integral of 2 pi y ds. So your r is going to turn into just y. And if you're rotating about the y-axis, you're going to do the integral of 2 pi x ds. Again, you have a choice about what you want to use for ds. Oftentimes it'll be made based on how the function is given to you. Now if you're running into trouble, remember that you can always try it using a different version of the ds. Alright, thanks for watching, and see you in the next video.